Welcome back, and we are going to wrap up this section now. We're going to have average rate of change, which we talked about before. Again, we're going to just reiterate it real quick and maybe try to relate it to some future concepts. So recall that the average rate of change between 2 points of a function f. For a nonlinear graph, the average rate of change between any 2 points x1, f of x1 and x2, f of x2 is the slope of a line through the 2 points. The line through the 2 points is called the secant line. So the secant line, it's an important terminology that we're going to, again, reference later on. And the slope of this line is denoted by m sub sec. So that's just to be very, very specific. And so now we can put it into our slope formula. So again, the change in y over the change in x. So let's quickly do that for our problem. And again, it's not a terribly difficult problem per se, but you just have to be careful when you substitute in those numbers. So if we wanted m sub secant, so again we want f of x2 minus f of x1. So x2 is 5, x1 is negative 1. So let's substitute that in. So we got 5 to the third minus 3 times 5 squared minus 5. And I'm going to use my square brackets again. Because we got a number that we're substituting into a function, we want to just make sure that we are careful with the signs. So negative 1 cubed minus 3 times negative 1 squared minus a negative 1. So there should be our change in y. So now our change in x, remember, is x2 minus x1. So 5 minus a negative 1. And now it's just order of operations. So I'll go over here. So 125 minus 25, if we square it, times 3, which is 75, minus 5. Cubing negative 1, we get a negative 1. Negative 3 times a positive 1 would be a minus 3. And then another plus 1. And we can see on the bottom that we should get a 6. All right, and then do a little bit more on top here. So we got 125 minus 75, which is 50. 50 minus 5 is 45. So we got 45 minus, and then we got negative 1 plus a negative 3 is negative 4. Negative 4 plus 1 is back to a negative 3. So minus a negative 3 all over 6. So 48 over 6, which is 8. Again, just be very careful with those signs and those negatives because they can be a pain in the rear. So, okay, the last application of functions we're going to see here in 1.5 is even and odd functions. So we're going to be looking at 2 types of symmetry related to this terminology. So if we have symmetry with respect to the y-axis, it will be considered even. And if it's symmetric with respect to the origin, not the x-axis, then it will be an odd function. So that's the definition. How do you test for it? Well, it's all based off of what happens to the y value when you substitute in negative x. So if you substitute in negative x into the function and you get the original function back, that will tell you it's even. If you substitute in negative x for x into the function and you get a negative of the original function, then it's odd. So we can see this pretty quickly. So remember, we want to substitute negative x in for x and just see what happens. So we have to negate x and raise it to the 6th power. You want to subtract 2 times negative x to the second, and then we want to add the 3. So if we raise negative x to the 6th power, all those negatives are going to cancel out. So we'll end up with a positive x to the 6th. Same problem here. Negative x to the 2nd power, the negatives will cancel, so we'll have a negative 2x squared, and then we still have the plus 3. And lo and behold, it's the same as the original, so this equals f of x, so that means this is even. All right, now if we do the same thing here, so we can substitute negative x in, so negative x to the 5th minus 5 times negative x. Well, we're going to have 5 negatives. 4 of them will cancel out with 1 left. So we'll end up with a negative x to the 5th power here, and the 2 negatives will cancel and become a positive 5x. Well, that is not the same as the original. So it's not even. But if we factor out the negative, we can see that this is the same as the original. So we are getting the negative of the original function. So that means that this one is odd. And now, is that it? Well, I got a third one for a reason. So if we substitute in negative t, and we get our negatives in there, so we'll have that to start with. The negatives will cancel out because we're squaring it, so we'll end up with a positive t squared. Here there's 1 negative, so we'll have a minus 2t, and then we have the minus 3. That is not the same as the original. So this would mean it's not even. But is it odd? Well, let's find the negative of the original. If we negate the original function, we'd have something that looks like this. So again, we're negating the whole thing. And now when we distribute, that doesn't look like what we got up here. So it's not odd either. So in this case, our conclusion is that it is neither. Neither odd nor even. Now this is the algebraic way to do it. Are there other little shortcuts that you could kind of employ? Yes. And the only hint I'll give you on that is look at your exponents and relate it back to your determinations and see if you can develop a relationship there. And if you want to know more, ask questions. So that wraps up 1.5, so we will see you in the next video for 1.6. Stay tuned.